Hello, and this week's video is going to be about separable differential equations and finding the solution to them, or like a partial solution to them. So first, let's go over the kind of general method of approaching a differential equation. And what I'm talking about in this video is when you have your derivative given to you that's going to equal something, and you're either simply asked to find the equation, so the equation of y, you're asked to find y equals blah 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 in terms of x, or you're also given a point, given AB, so the solution passes through AB, and then you have to find a more specific solution. Here you would still have your constant c, but here y equals blah blah blah, it would only be in terms of x, and there would be no c. So, but this is going to make sense in a couple of minutes when I start doing examples with you. So, the first step is to separate the y's and dy's from the x and dx's. So on one side you're going to have y and dy, and on the other side you're going to have x and dx. And then you're going to, this is just going to make it so much simpler, because obviously you can kind of see what this is hinting at, can't you, right? And you need them separately in order for this to work. And then you would integrate both sides. And I want you to ask the questions of why you might want to do that. Well, if you remember that an integral is just an antiderivative. So if you're taking and integrating the derivative of the function, you're going to get your initial function. So say you have f prime of x, and you integrate that, that's just going to give you f of x. And then lastly, if we have a value that's given to us, so if the solution passes through a point AB, we substitute that given value to find c, and then we have a more specific solution. So let's do two examples. One a bit more general and the other one a bit more specific. So this is our first question, and in here we're going to be asked to find just a general equation for y in terms of x, and here we're going to end up having a c, so a constant that we're adding, because we're not given enough information to find which specific function this question might need. So once again, as mentioned before, first let's separate the y's from the x's, and really important, I put this as f prime of x so that you wouldn't be confused, because f prime of x is just the dy dx derivative of y in respect to x, and never forget that, because if you accidentally look at this and you're like, oh, I can't do it, no, just remember that this is the same thing as dy over dx. Alright, so now let's work with this right here. We're going to end up getting, and this is simply like cross multiplication, you're going to have cosine of x plus 3 dx is equal to 2y dy, right? Then we want to integrate both sides, which is going to give us our original function. And would you look at this? Oh, almost like it was meant to be, guys. Alright, so now we can integrate. And for this over here, the antiderivative or the integral of a cosine function is just sine. So you're going to have sine x plus 3 is equal to, and then 2y plus another power over a half, so you're going to have y squared, right? This is going to, let me just quickly show you, 2y, y plus 1, this is y to the power of 1, so you're going to have y to the power of 2 over 2, these cancel out, you just have y squared, alright? And then don't forget your constant c, and it doesn't really matter which side you add it on, and you don't have to like change minus plus, because once again c is just a constant, and like it's still going to be a constant even if it's like minus plus, it's just going to be a different one, but it's still going to get you the same results. You know what I mean? Alright, so now we simply just have to solve, because now we have our y's. So what do we do next? Let's separate this a bit. We're going to have, and let's put the y on the left hand side. We're going to have y squared is equal to sine of x plus 3 plus c. And then our y is going to equal to the square root, or positive or negative square root, of sine of x plus 3 plus c. And here you do have to square root the constant because you're not just adding it now. So you can't, it simply doesn't change like that anymore. So you have to actually square root it. And yeah, so this is going to be our general solution. And this is as precise as we can get in this situation right here. But if you look at our next example, you're going to see that this can grow in being more specific to the function that's given. And let's look at the second example and show what I mean. Alright, so our second example is going to be a bit more specific, and we're going to have the derivative of y in respect to x is going to equal to negative x over y times e to the x squared power. And we have to find a solution that goes through the point of 0, 1. And you'll see why this is more specific. We're going to actually end up having a value for c. So first, let's separate these x's and y's from each other, and I'm just going to times dx onto the other side and times y onto the other side. So we're going to end up having y dy is equal to negative x, and I'm just going to write it 1 over ex squared dx. And this can also be written as negative x e to the power of negative x squared dx, just with some exponent rules. So now let's integrate this. We're going to have to take the integral of y dy. And once again, I'm reminding you we're doing this because the integral of the derivative is just going to give you the function itself, because the integral is the antiderivative. And if you're taking the antiderivative of the derivative, you're going to end up getting the function itself, is equal to the integral of negative x e times e negative x to the power of negative x squared dx. So the first hand side is pretty simple. You're just going to end up using the power rule again. Right now we have y to the power of 1, so we're going to have y to the power of 2 over 2, which is going to give us 1/2 of y to the power of 2. But on the other hand, over here we're going to have something a bit more complicated, and we're actually going to have to use a bit of u substitution. So let me get out a sticky note so I make this quite clear in its separation from what we're doing. So let u be negative x squared. So then du in respect to x is going to equal negative 2x. So du is going to equal to negative 2x dx. And then here, if we apply this here, we're going to have the integral of, and we have to make this even, so we have to put 1/2 in front. And then we can do negative 2x times e to the power of negative x squared dx. And if you recognize this and how it's over here, this is just du, so we're going to end up having 1/2 the integral of e to the power of u du, and that's just going to equal du. So we're just going to have 1/2 e to the power of u plus a constant. And if we plug this back in here, we're going to have 1/2 of e to the power of negative x squared plus a constant. So if we put this back in, it's just the same thing. 1/2 times e to the power of x squared. Don't forget the constant. So now we have to apply the point given. Or you can rearrange for c first, however you want to. I'm just going to put the value straight into this equation right here. So we're going to apply the point of 0, 1. So we're going to have 1/2 of 1 squared, which is going to be 1, is equal to 1/2 of e negative 0 squared, which is going to be 0 plus c. So we're going to have 1/2 of 1, which is going to be 1/2. 1/2 is equal to 1/2 of e to the power of 0. Anything to the power of 0 is just 1. So 1/2 times 1 is just going to be 1/2 plus c. So 1/2 minus 1/2, well, c has to equal to 0. So what do we know? We know that c is equal to 0. And I'm just going to erase this over here so we have some space. And now is the time where I would rearrange. So we have 1/2 of y squared is equal to 1/2 of e negative x squared plus 0, so plus nothing. And we're going to rearrange to solve for y. So we're going to have y squared is equal to 2 times 1/2, which is just going to cancel out. So, but I'm just going to write it out either way. That cancels out, e negative x squared. So you're going to have y is equal to the square root of that, positive or negative, e negative x squared. And I want you to really think whether this one is going to be positive or negative. And a hint is to look at over here. Well, our y is positive, and there's no way we're getting a positive from a square if it's not the positive square root. So we're going to have a positive square root. So we can erase that symbol and just put a positive or none at all. And this can be then simplified to y is equal to e to the power of negative x squared to the power of 1/2, since a square root is just to the power of 1/2. And then y is going to end up being, this can further be simplified to, once again, with some exponent rules, to y is equal to e to the power of negative x squared over 2. We just multiply 1/2 times negative x squared. So this is going to be our final answer. And in this case, c was 0. If c was not 0, it would be a bit more, there would be a bit more complexity to the distribution of, for example, the exponents. But in this case, it was really simple because c was just 0. Alright, so I hope you enjoyed, and I hope you're more familiar with how to solve differential equations, both more general and more specific, and see you next week.